Good morning, everybody. It's Miss Pollock here, and I'm going to walk through a collision question. In class, each one of you is going to do this type of question. So I thought I'd go through it and just to make sure that you knew kind of how the steps to take. So here I have a 2 kilogram cart moving at 9 meters per second. It's going to collide with a 0.5 kilogram cart moving at negative 6 meters per second. And after the collision, we're going to assume that the 2 kilogram cart travels at 4 meters per second. So it asks, how much mechanical energy does the cart-cart system have before they collide? And the only way to do this is to find the mechanical energy, to calculate it. So the mechanical energy in this case is all kinetic energy. So if I call this cart A and this cart B, we can say that the mechanical energy or the kinetic energy is just the 1/2 mass of A times the velocity of A squared plus 1/2 the mass of B times the velocity of B squared. And then it's just algebra from here. The mass of cart A is 2 kilograms. The velocity is 9 meters per second. Need to make sure to square that. Plus 1/2 the mass of cart B, which is 0.5 kilograms. And the velocity is minus 6 meters per second squared. So when I go through that algebra, I find my kinetic energy is 81 joules plus 9 joules. And so when I add them together, it ends up being 90 joules in my cart system before they collide. Then it says, what's the velocity of my 0.5 kilogram cart after the collision? Well, we can do one of those diagrams that we've been talking about to kind of give us a guess of what's going to happen, or an estimate. So here I have my cart system. And those are interacting with the track, and they're interacting with the earth. And we can say that to begin with, cart A has a bigger mass, right? And it has a lot of velocity. And it's moving in a positive direction. B, on the other hand, has a much smaller mass, right? Much narrower blocks. And it's not moving as fast, so it doesn't have as many blocks. So we can see before we even do any math that cart A is going to be moving slower, so it's going to have a smaller height. And in order for those mass velocity blocks to be conserved, we must have a much higher velocity for B because it has a smaller mass. So let's go through that math. We know that we need to conserve those mass velocity blocks. So my mass of A times my velocity of A plus my mass of B times my velocity of B will equal my mass of A plus my new velocity of A, or times my new velocity of A plus my mass of B times my new velocity of B. That's all the physics now. The rest is just algebra. 2 kilograms times 9 meters per second plus 0.5 kilograms times negative 6 meters per second is 2 kilograms, and it was given that it would be 4 meters per second, plus 0.5 kilograms. And this is what we're trying to find, my new velocity of cart B. When I go through that math, I end up with 18 kilogram meter per second minus 3 kilogram meter per second equals 8 kilogram meter per second plus 0.5 kilogram times the velocity of B. And when I end up doing that algebra, that ends up being 14 meters per second. So it did end up going faster after the collision. The next question is, what's the velocity of the center of mass of the cart system after the collision? We talked a little bit about what the center of mass is, the weighted average of where the center of my system is. So, in order to figure that out, when I have masses that are different, so my velocity of center of mass, that's how I'm going to write it, velocity of my center of mass is mass of A times the velocity of A plus mass of B times the velocity of B divided by the sum of the masses. So in this case, my velocity of the center of mass, 2 kilograms times 9 meters per second plus 0.5 kilograms times 14 meters per second, because this is after the collision, divided by 2 kilograms plus 0.5 kilograms. And when I do that algebra, that ends up being 10 meters per second. So the velocity of my center of mass after the collision is 10 meters per second. Then it says, how much mechanical energy does the cart system have after the collision? Again, to find the mechanical energy, what kind of energy is there? Only kinetic energy. So I have to add the two kinetic energies. 1/2 times the velocity of 1/2 times the mass of A times the new velocity of A squared plus 1/2 times the mass of B times the new velocity of B squared. That is 1/2 times 2 kilograms times 4 meters per second squared, because this is after the collision, plus, oops, sorry about that, plus 1/2 times 0.5 kilograms times 14 meters per second squared. And when I do that math, I end up with 65 joules. You can tell that my kinetic energy went down after the collision. And that's because some of that energy was transferred into E-dis because they collided. All right, I hope that helps with what you're going to do tomorrow in class. As always, have a great sunny day. Bye.